Hello, in this video I just want to address some of the concepts behind function, domain, and range. This is intended to be pretty much a review from college algebra. So pause the video and ask yourself, what is the definition of a function? And can you think of an example of a function? And what I'm going to do is go over some ideas that are and examples of functions that are not numerically based necessarily, so that it's not just mathy. Okay. So think about a function. What do you think the definition of a function is? And can you come up with an example? All right, so hopefully you have something like this. A function is a rule of correspondence such that each element in the domain has one and only one element in the range. So a little bit simplified, that's a rule of correspondence for which each input, right, that's an element in the domain, has only one output. That's an element in the range. The output is an element in the range. So a rule of correspondence is a way of pairing the input and the output. And there's so many ways of pairing them, right? So if I said y equals 2x, for example, and I know this is mathy at this point, but when I put in x equals 1, I pair it with the output y equals 2. If I put in the input 5, I pair it with the output 10. But if I have y equals 5x, it's a different pairing. When I put in 1, I used to get 2, now I'm going to get 5. When I put in 5, I used to get 10, now I'm going to get 25. So it's a different pairing, okay? So that's the rule of correspondence, is how are you pairing? What set of rules do you have that pair one input with an output, okay? Now, what's really important here is that for each input, there's only one output. That's it. So why is that? Well, let's say you got on a bus and you wanted to go to place A. Well, you totally expect that when you get on this bus at this bus stop, that eventually you're going to end up at A, and that's it. But what if you could get on that bus and you might, let's say it's a non-stop bus. You get on it and there are no stops along the way and you end up at your terminal spot. That's it, right? So it's like a sort of a long-term journey. So you just get in and you're supposed to end at place A with no stops in between. Well, that is a function, right? I put in something, I get on this bus, and I end up so in this location, out at that location. So for this input, there's only one output. But what if I got on this bus and maybe I could end up at A, or maybe I could end up at place B, or maybe I could end up at place C, and I don't know which one it's going to be? Well, that would be kind of, it would create anxiety probably. I wouldn't know. I have a lot of uncertainty. Well, where am I going to end up? Unless I'm on an adventurous day and that's all I want, this wouldn't work for me. It just doesn't work. So the idea is, I need to know what's going to happen, right? That's important. So let's take another example. Let's say you take a vending machine, and if you recall, on a vending machine, essentially what you have, you usually have rows, and then you have, each row has a number, and for each number there's an associated item, food item, right? So let's say A2 has Doritos, and B3 has potato chips, and C4 has Snickers, and D1 has Snickers. So is this a function, right? So the idea is, what I want is I plug in, let's say, A2, and of course I have put the money in, and what comes out are Doritos. And what I want is just Doritos because that's why I chose it. Well, what if I put in A2 and instead of getting Doritos, I got Lifesavers? That would not work, right? I'm expecting Doritos, which is a possibility, but I ended up getting another possibility. And I'm not happy about it. So I spent money on it and didn't get what I want, right? So is a vending machine a function? Is it set up to be a function? Yes, it is, right? You know that when you put something in, one input, you're only going to get that one output that you see, right? Now, is it possible to have two different outputs in a vending machine? Is it still a function? So is it okay that I press C4 and I get Snickers, and I press D1 and I get Snickers? Well, in each case, when I press C4, do I know exactly what I'm going to get? Yes, I'm going to get Snickers, right? When I press D1, do I know exactly what I'm going to get? Yes, I get Snickers. So the idea is it's okay if more than one input takes me to the same output, but what's important is that each input takes me to only one output. Why? I need predictability. I need predictability for this to be functional for me. Literally functional. So it's a function. All right? So that's the basic idea as to why we define functions as a rule of correspondence, right? In this case, it was a way of pairing, let's say, my input A2 with Doritos, for which each input has only one output. I press A2, I expect only Doritos and not anything else, okay? All right, so hopefully that helps you not memorize, and you may have understood that, I don't know. All right, so domain and range. So for domain, it's the set of all inputs. For range, it's the set of all outputs. But the idea is domain is really about what's allowed in, what's valid. And range is about, well, what's possible, right? So suppose you're organizing groups of Florida high school students in the ages from 14 to 19, and they're arriving at an event. So to recognize which high school a student is from, you use colored t-shirts. So the idea is the inputs are certain high schools from Florida. The outputs are certain colored t-shirts. So somebody from Awesome High School gets a green t-shirt, somebody from Liberty High School gets a blue t-shirt, and so on, right? So is this a function? And ideally, yes, it should be. If it's used properly, it should be. The idea is if somebody from Liberty comes up and shows their proof of ID, and then you say, okay, great, you get a blue t-shirt, and that's all you get. You don't get any other color. That's it, just blue. So then I can recognize you easily, and you, for this input, there was only one output. Now, it's okay that many inputs got that output. That's fine, right? Just like the Snickers, it's okay that more than one input goes to the same output. That's actually fine. But you have to have it so that only each input only has one output for it to be a function. Okay. Now, what would be an invalid input? Well, it would be something that would make this thing sort of blow up, like the person at the desk, right, who's giving out t-shirts, all of a sudden doesn't know what to do. They're like, I don't know what to do with you. You're not a valid input. So what might that look like? Well, let's say somebody from Alabama, let's say a 16-year-old who's in a high school in Alabama comes up to the desk and says, hey, I want a t-shirt. I want to be part of this event. And you're like, great, what high school you're in? And they're like, it's not on here because they're from Alabama. And you're like, I can't give you a t-shirt. So that's the idea. You don't know what to do, right? It's not valid. And then the range is what are resulting possibilities. What's in the realm of possibility once you have, consider what are all the possible inputs that are valid? Well, in this case, it's all the different colored t-shirts that I have here. So if I have all these t-shirts, and this is ... means you're handling all the high schools. But let's say you never, ever, ever see ivory in here. Then that's not a possibility. So it's not part of the range. Okay. Well, let's take a look at, here's some, a chart with age, so in months. And let's take a look at height in centimeters. So let's say you're looking at baby girls, there's whatever age they are and what heights are generally, here it says 3rd to 97th percentile. So let's say you take a 5-month-old baby girl, and generally they should their height should be something like the 59.9 centimeters to 68.2 centimeters. Now, in this case, I don't think they're necessarily saying it's impossible for it to be anything else. If we went from the 0th to the 100th percentile, we really would be catching everything. But let's just say, just think about it, common sense. If you take a 5-month-old baby, do you think that they could be 2 centimeters? I don't think so, right? I don't even think, it's just not even possible, right? Or do you think they could be 500 centimeters? Not possible. So we're talking about, like, what is possible? So if I were to ask you, let's say you take a look at a 20-year-old women. Just common sense. What are all possibilities you could think of their heights? Well, even if we exaggerate quite a bit, I don't think they could be less than 2 feet tall, and I don't think they're going to be more than 12 feet tall. It's probably going to be an even more narrow range than that, but just say, right? So just using common sense, certain things are just not possible. And that's what we're talking about, range. What is possible? Okay. All right, now let's take a look at graphs, because that's where we're headed, really. So what are the domain and range of graphs? When you're determining the domain for a graph, since the domain is graphed on the horizontal axis, you need to scan from left to right, on the horizontal axis, and then to see what inputs are valid. And the order in which you scan matters. You must go start from the left and go to the right. And then for the range, that's graphed on the vertical axis or the y-axis. So this is domain is on the x-axis, y is on the outputs are on the y-axis or vertical axis. So you're going to scan from bottom to top, and again, the order matters. You want to see what what do they say here? Bottom to top, to see what, not inputs, but what outputs. Sorry about that. Are possible. My apologies. I think that was a copy paste. All right, so let's see here. So for range, you want to go from bottom to top, and you want to start at the bottom. The order matters. You start scanning from bottom to top to see what outputs are possible. Okay. So I've got a few examples here. Let me get a couple of the other ones out of the way. So here's just a basic generic line, right? And if you're scanning for the inputs, what's valid, notice you have the arrows. And what that means is as you're scanning from left to right, for every input, does it take you to an output? So if I pick this input, right, where does it land? Right there on that line. Well, it had somewhere to go, so it must have been a valid input. So the idea is as I scan from left to right, if I'm touching graph, it's because there was an input that went to an output. That's how that graph was created, all right? So, and because this goes on forever and ever, the idea is everywhere I scan from left to right, there's graph, therefore the domain is what they call all real. That's one way of writing it, is just that big R with the 2 little lines here. Or you could write negative infinity to positive infinity, right? And that means, again, all real. And notice that these are parentheses, meaning the endpoints are not included, because you can't include infinity. You can't bound it, so it has to be open. All right, so that's the domain. Everything's possible. You can put every number in here, meaning any input, that input there, it sends me somewhere. There's graph. I have somewhere to land. So then output is basically scanned from bottom to top. And again, since this goes on forever and ever, there's always graph, there's always graph, there's always graph, there's always graph. So all values from negative infinity to positive infinity are also possible for the range. So it's all real, or you can say negative infinity to positive infinity. Okay. So let's take another example. So here we have a parabola, and the idea is this vertex is at negative 10. So as I'm scanning from left to right for the domain, well, these arrows go on forever, so this continues on forever. So there's always graph. I'm always going to touch or run into graph as I'm scanning from the left to the right. So the domain here is all real, right? Or you could say, again, negative infinity to positive infinity. Now the range, as I'm scanning from the bottom, there's no graph. It just doesn't even exist. So that means not every possible output, right? There's not every possible output. In fact, when's the first time I have an output? Well, it's at that level negative 10. So like there is no input that will take me to the output, let's say negative 15. It just doesn't exist. I can't do it. I can't get there. That would be like saying, is there a way a human can be 30 feet tall? Nope. Sorry, it doesn't matter what you feed it, what you do, sorry, it's not going to be 30 feet tall, right? Same thing here. You can't get below negative 10. So here the range begins at -10. And then after that, there's graph, lots of graph. And in fact, it's forever. And it doesn't matter that for a particular level, there's more than one input that can get me to that output. That's like the Snickers bar in the vending machine. More than one input sent me to the same output. That's okay. This input and this input send me to the same level. But it's that level is available to be mapped to. So really this goes to infinity. And here I would want to include that point because I'm allowed to land on -10, right? In terms of the vertical motion. So this is a closed or included value. Okay. Now I've got one more, and I ask you to pause this. I purposely made this a little bit more difficult, so you really have to think about it. And I hope I labeled every point I need. So we'll see. Pause this and see if you can find the domain and range. This should really kind of tease out, I hope, questions that you may have. All right. So then when you unpause it, we'll go through it. So here we go. As I am scanning, and let me get a different pen so you can write. As I'm scanning over here, there is no graph, right? There's no graph here starting from the left for my domain. So actually, let me write this here, domain. Remember, you're going from left to right. All right, the first time I have an input that actually is taking me somewhere is over here at -12. I move over -12, and then I'm sent down here to -15. So really, I'm -12, and is it someplace that I can actually land? Yes, so it's included, right? And how do I know? Because it's closed, right? And then after that, I have every input, like 12.000, I'm sorry, -12.000. No, that's not true. I just made a mistake. That would be going this way. Let's say a -11.9999999 would take me over here really close, and so on and so forth, right? And then what happens here at -8? At -8, I can't land here at -9 because it's open. Can't land there. But is there a place I can land? Does -8 actually, is it an input that's valid because it actually sends me somewhere I can land? Yes, right there at -7. So actually there's no break in the possible inputs that are valid from -12 all the way through -8 and even beyond, right? Because at -8 I go to -7. At -8.0001 going that way, I'm right here. And then at -8 I'm here. And then, you know, I go here, and then like at -5, I go to 3, and so I have a place to go everywhere, all the way, right? So all inputs from basically -12 all the way to 4. And then at 4.00001, is there anywhere to go? No, right? I can't go anywhere. So really, there's going to be a gap here. I'm allowed to land on 4 does send me somewhere where I can land. I'll end up landing at -2, but 4 is a valid input. So that's closed. All right, so essentially everything from -12 to 4 has graph, meaning I had an input that sent me somewhere. But all of a sudden, between just past 4 going to the right, I don't have anywhere to go. There's no graph, so I can't go anywhere. Therefore, those were not valid inputs. There's nothing there. And then here at 6, I can't land on 1, I can't do it, but I must be really close because at right past 6, and when I say right past 6, I mean 6.0000000000000, you know, you get the idea, 1, I can land somewhere right there, right next to it. So the idea is this is union, meaning all of these are valid, or all of these are valid from 6, but I'm not allowed to land. 6 doesn't actually send me somewhere, so I'm letting you know that just past 6, as we go from left to right, I will be able to put inputs like 6.001. And so on and so forth. I have graph, so I have graph, until I hit 9, right? Well, at 9, can I land there? No, I can't, but was 8.99999999999, etc. an input that sent me somewhere? Yes, at 8.999 I went right here. So I can go all the way to 9, but I can't, it's not a valid input because exactly at 9 I have nowhere to land. Can't do it. And then past going this way, left to right, past that, but for numbers between 9 and 11, I can't go anywhere. There's no graph. So then 11 is the beginning, right? So union, 11, and then is it closed or open? It's open, so it doesn't actually send me anywhere, but just past 11, 11.001, I will be able to go somewhere, right? It's an input that will take me somewhere, so it's valid. All the way up to 13, but also not included, right? So that's the domain of this graph. So now pause again, like maybe there were a few little issues. Pause and do the range. Write down what you would get for the range. Remember, you scan from bottom to top. Okay. So now as I'm going from bottom to top, there's no graph, no graph, no graph, no graph, until I hit -15. Sorry about that. Readjust. No graph until -15. And can I land there? Yes. So I have from -15. And then from there on, remember, I'm scanning this way. I'm here. If you say, oh, can you reach down to -8.5? Yeah, right? There's some input around here that'll send me about to 8.5. But what about -8? Can I get to -8? Yeah. I'm sorry. Can I get to -9? My apologies. -9 is the output. So there are inputs that send me from -15, values from -15 all the way to not quite -9 though, right? So can I get to -9.00001? Yeah, right here, right? This input would take me right here. But I can't really figure out a way to land on the output -9. So -9 is open. I can't get there. So if you say somehow put something in, put in a value that'll make you land right there. Can't do it. It's open. And in fact, there are a lot of Y values, like from -9 all the way to almost -7. I can't land there. If you say, can I get there? No, there's no graph. See, it's empty. So then I really have a break, right? So union, and then -7. Can I land on the Y value or the output -7? Yes, I can. So you have -7 and it's closed. Right? And then you have, can I land on these values? Yes, right? Now what happens here where there's cross, right? So whatever this output, which is here -2, there's more than one way I can get at -2. So if you say get to the output -2, well, I can do it here or I can do it here. But can I do it? Yes, I actually have more possibilities than just one possibility. So definitely all the outputs from -7 to, let's see, here, here, here. Here I have what, 3 ways of getting to that output. And even though that's open for the output 1, it's closed here and closed here and closed here. So there's 3 ways I can get to 1, even though I can't do it from this particular input. So I have graph this way. So I run into graph. There's places to land. Even at 3 I do. And even past 3, I can't go any more here, but I can go here. There are inputs here that will take me to values that are more than 3, right? So I actually have all values from -7 all the way up to what? Looks like 7. But can I actually land on 7 itself? No, I can't, right? I can land at 6.99999 going this way, but I can't at 7, okay? And then I can't actually land on any, there's no graph here going up and down. There's just nothing right here. So if you said get to 8, +8, there's nothing. I can't, if you say this input, well, this input's sending me here. Is there any way I can get up here? Nope. You know, and so on and so forth. If I'm here, can I put anything? Nope, I can't get there. I just cannot get to 8, 8.5, that kind of thing. So what can I get to? I can get to 11, but not where I'm landing on it. I can, if you say get to the output closest to 11, it's 11.00001 going this way. And then, you know, I have graph, graph, graph. I have all these outputs all the way up to what? 15, but not exactly 15. I can get to 14.9999999. Okay. So that's my range. So hopefully this kind of helped you really tease out questions that you may have had for domain and range and functions, and certainly finding domain and range from graphs. All right. Thank you for listening.